Here we go with some more statistics. We're going to talk about zinc in older Americans, so therefore let's look at this problem. Make sure we read carefully, make sure we define appropriately. If we do so, we can see that this 15 is given as our mu. We also are given a sample mean of 11.3 with a standard deviation of 6.43, so that's S of x. We also know that it's given that we have a sample that is random of 115. So that's our n. So if we're going to define the parameter of interest, the first thing we want to do is remember that the parameter of interest is mu. Okay? Therefore, defining it, we are interested in the mean intake of zinc for males aged 65 to 74. All right. Now we're also interested in establishing what our null and that was good. Our null and alternative hypotheses. So we're going to write H sub O and H sub A. We know we're talking about mu. And now we're going to look for what it says in the problem. Okay? In the problem, it asks us, older males are not getting the RDA of zinc in their diets. It continues to say, does this data suggest that the average daily intake of zinc for older adult males is less than? That's our key. Is less than goes with H sub A. Therefore, we could say greater than or equal to for H sub O. And we will use mu, which is 15. Hopefully, so far, this is making sense. This is rocking and rolling. You're thinking, awesome, I know what I'm doing, Mr. Walton. Woo-woo! Summary stats. Here we go. We know mu is 15. We know x bar is 11.3. We know S sub x is 6.43. That's the standard deviation of the sample. All right. We know that n is 115. We also therefore know that the degrees of freedom would be 114. We now know that the standard error, which is equal to S sub x over the square root of n, can be calculated as 6.43 over the square root of 115. So I can leave it like that so that I can plug in and calculate my test statistic t, which is going to be x bar minus mu over the standard error, which will give me negative 6.17. Now that we have all of our summary stats, what do we go to next? We've got to have our beautiful and lovely. All right, so now we need to have our conditions. Don't forget, conditions are important. First, we have S, and it is given that a random sample was used. For independence, we are talking about men. It is reasonable to assume there are more than 1,150 men aged 65 to 74, which is 10 times 115. Therefore, our subjects should be independent. And n, since 115 is greater than or equal to 30, the sampling distribution should be approximately normal. Continuation statement. Since our conditions have been met, we will continue with a one sample t-test. And now, don't forget our beautiful picture. Oh yeah, beautiful picture. And our probability statement. We have 15, 11.3, shade to the left, which means write my probability statement as, what's the probability that this one sample or a sample with a mean of even lower than this, right, would happen in our sampling distribution? How likely is this to occur? Well, we would think that this p-value would occur about 5.3 times 10 to the negative 9th, which means I just don't think I should get that. Approximately 0 is our p-value. If we look at the next question, it asks us, how likely is it that we would get this sample mean? Well, based on the fact that I got 0 or very close to 0, I would say it's highly unlikely. Okay? If you want to write that out as a statement, that's good, well, nice. However, it's really highly unlikely that that would occur. And then for our money statement, we have our 3 parts. We're going to first state, since our p-value is lower than any standard alpha level, we reject H sub O. Now let me explain. Standard alpha level. Standard alpha level. Let's look right here. That would be 0.1 or 0.05 or 0.01. Well, 0 is less than any of those. So we would reject H sub O at any of these standard alpha levels or levels of significance. Therefore, okay, the evidence suggests that the researchers' claim is valid. It seems that older males are not getting enough zinc. On a daily basis. All right, and here is an example of a one-tailed t-test.